Now, if you look at this question here, this one says make k the subject of the equation. And if you look at this other one, it says make x the subject of the relation. So basically, it's all the same. This is an equation. This expression is an equation. So now that's why when you see this, know that is the same as this. So what make them relations is because of the equal sign that make them relation. So when I said equation, it means the same thing. So students should not be confused about these statements when they see. Now from there now here, the questions ask us to make k the subject of the formula. So now solution, we are going to now make k the subject of the formula or the equation. Now basically now, what we are going to do now, our intention is to make k the subject of the formula. So now we are going to start it. We said y equals to 1 over 2 into a plus b k. Now, if you do this now, what you are going to do first, we are going to think of expansion. You have to expand the bracket to eliminate the bracket. Expansion simply means to eliminate the bracket. So now what we are going to do now, we are going to over this by 1. It's like this is a numerator on top, and this 2 is a denominator like this. They are all down. So mean 1 times a plus b. 1 times any term is that term. We maintain that term. So now we are going to have y equals to a plus b all in bracket k all over 2, because 2 times 1. I told you when I over it by 1, these are numerator, like the one is the way the one is on top. They are all numerator. Remember this term is there. So now we are going to expand the bracket by k. K is the one that is going to eliminate the bracket, expand the bracket for us. So now we are not going to start multiplying by here. No. We are going to start multiply by a first, second by this, because this can be changed anytime. It can be here, and when it is here, it has to multiply by the first term. So now what we are going to do now, we are going to set y equals to k times a is going to be ak, alphabetical order. That's how you arrange them. So it's going to be ak plus k times b, bracket mean times, is going to be bk all over 2. There are two methods which you can apply here. First, you find the common factor. Second, you can find the LCM. If this term is fraction, you make this other part of also as a fractional part by saying this is over 1. Most of the students like this. From there, you cross multiply. So when you cross multiply at this point in time, since our aim is to make k the subject, k is in the left hand side. So now we start this. 1 times this term is going to be, I told you 1 times any term is that term. So it's going to be ak plus bk equals to 2y. 2 times y is going to be 2y. So now from there now, k apply. K appear on both sides of the expression. It's like this. This is an expression. So what we are going to do, we factorize k. When k appear on both sides, you factorize it out. Factorization means you take it out. So k is out. So now when this k cancel this k, or when k into this k is 1 time, 1 times a is a, plus when k here 1 times b is b, close your bracket equals to 2y. Good. This means implied. So let's look at this part. Now this is what we have. We have k into a plus b equals to 2y. So now from there now we want k to stand alone, and k is with this term. Divide by that term. Divide both sides by a plus b, and here also a plus b. So therefore this only one stroke, they will cancel. So what left there is going to be only k. Therefore k is equals to 2y all over a plus b. This is the final answer. And another method which I want to apply in this point in time here, because some students will like cross multiply, some they will multiply the common factor on both sides. So now I will rewrite the question back again here, so that any method you feel like you can take it, because exams is like you are in your own choice. Any method you feel like you can apply it, but the most important things, your answers must be the same. It's like, for example, if you are going to Brikama, there are some people they can take short way to reach at Brikama, some the main highway. But at the end, the intention is to reach at Brikama. So basically, mathematics also is like that. You can use this method, somebody can use another method. Now let's look at the alternative method in this area. The alternative method, now this is what we have, y equals to 1 over 2 into a plus b k. I make this over 1. So now therefore we have y equals 1 times any term is that term. A plus b all in bracket k all over 2. So from here now we expand this bracket first. As I said earlier, k will first times by a. So now we are going to have y equals to ak plus bk. Now from there now we said all over these two. So now here I'm going to make here also as a fractional part, because here is a fraction. I make this whole variable as a fraction. So therefore I'm going to multiply it both by the common factor. What is the common factor here is 2. So you multiply here by 2 and there by 2. So now we are going to say 1 into 2 is 2 times. 2 times y is going to be 2y. Are we there? So now from there now, we are going to say now equals to 2 into itself 1 times, into here 1 times. So 1 times this term, the term will be still maintained. AK plus BK. Now from there, we are going to factorize because K is common on both. And our intention is to make K a subject, to stand alone. So we are going to rely this to y. 2y equals to, now let's factorize K out. So when K is out, K into K is 1 times. 1 times A is A. Some math teacher will tell you K cancel K. That idea is wrong because when K cancel K, so what about this other K? Nothing will be there to cancel it. So the same letter or the same number, when they divide each other, is always 1. So now K into itself is 1 times. 1 times A is A plus K into B, K is 1 times. 1 times B is B. So now our intention for K to stand alone divided by the term which K is standing with. So we are going to say A plus B. And this side, remember it's equation. Whatever you do to the other side, you must do it to the other side. So this is going to be A plus B. So now basically only one stroke because they are all the same. So now what left there now, this side is K. So we are now going to say therefore, our K is equals to 2y all over A plus B as the way. Now if you compare the two answers, they are all the same. It's the matter of the methodologies which I apply. But at the end, my intention is to make K to stand alone, and that is also being fulfilled as well. Now if you look at this, if you want you can take this method, if you want you can use this method. So far so good. These are some of the topics that normally appear, and this is Gabesi correction as well. Yeah, I could not remember the year, but it's Gabesi correction. Good.
Theorem. But today we are going to discuss about theorem 1 and theorem 2. So this other one is theorem 1, which says that angle at the center is 2 times angle at the circumference. Now the angle that is at the center here is y, and this one here is the circumference. So the angle that is in the center is going to be 2 times, that is, the first one is going to be angle that is at the center here is 2y angle at the circumference. So I will say my y is going to be equal to 2 times what? The angle that is in the circumference. That is 2 times what? X. So my y is going to be now equal to x. Are you seeing that? Sometimes they normally draw it in this form as well. So this one and this one, they are talking about the same thing. So the angle that is at the center here is x, and the angle that is at the circumference is y. So I will say here x equals to 2 times y. 2 times y. So my x now is going to be equal to y. So if you know the value of this x here and they ask you to find the value of this x here, half of this one here will give this one to you. Are you seeing that? But if they give you the value of your y and they ask you to find the value of x here, so the angle that is in the circumference here, you are going to multiply that one by 2, then you will know the angle that is in the center. Are you seeing that? So here also the same thing. So this other one also is the theorem number 2, theorem 2, which says that the opposite angle of a cyclic quadrilateral is added up to 180 degree. That is, if I add these, the opposite of these two here, if I add them, their sum is going to be equal to 180 degree. So I will say x plus y, their sum is going to be equal to 180 degree. That is opposite angle of a cyclic quadrilateral is added up to 180 degree. So here also z plus double must be equal to 180 degree. That is the same reason. Opposite angle of a cyclic quadrilateral is added up to 180 degree. The same thing here also. If you look at this one and this, they are talking about the same thing. So opposite angle of a cyclic quadrilateral is added up to 180. So if I add these two, their sum must be equal to 180. So my A plus B must be equal to 180 degrees. So the same reason. Here also your C plus B must be also equal to 180 degrees. That is opposite angle of a cyclic quadrilateral is added up to 180. Sometimes in WAS exam, they might bring 3 theorems in one question. So as a student of knowledge, you must have to master all these theorems in order for you to attempt questions in WAS exam. Because if you look at this WAS exam, they brought almost 3 or 4 circle theorems. So some students find it difficult to solve question on the circle theorem because they don't master these theorems. And you cannot solve question under this circle theorem if you don't master the properties. Do you understand that? So as a student of knowledge, you must have to master all these things in order for you to solve question on the circle theorem. So we are going to only solve these examples. It says that find the angles x, y, and z in the diagram below. That is, find the angles x, y, and z in the diagram below. So when you look at this one here, it's a typical example of these two theorems. I've seen that. So if you look at these two theorems here, they all reflect here. I've seen that. They all reflect in these examples here. So looking at the first one here, if I put my hand here, I will see the first theorem, which says that angle at the center here is twice angle at the circumference. That is the first one. I've seen that. That is the first theorem. If I also put my hand in this other one here, it will take me back to this one also, which says that opposite angle of a cyclic quadrilateral is added up to 180 degrees. So if I add these two, their sum must be equal to 180. So now I need to find the value of my y first. Now after finding the value of my y, then I will find the value of x. If I find the value of x now, obviously I will easily know this other one because this z here is at the center. I seen that. So in order for me to find the value of z, I need to find my y. Then from y, I find this one. We are going to use the theorem 1. It says that angle at the center here is 2 times angle at the circumference. So now we are going to write our solution. Now the solution is now we are going to apply the theorem number 2, which says that opposite angle of a cyclic quadrilateral is added up to 180 degrees. So I'm going to set y plus 126 degree, then equals to 180 degree. Sometimes in exam, they will tell you that with reason. So you need to indicate it there as well. So that is opposite angles of cyclic quadrilateral. You can put it in this form. I seen that. So now here, what we are going to do here, this is an equation. So we need to collect our like term. So there, my y now is going to be equal to 180. If I take this one to the other side, the sign will change because here is positive. So it's going to now 180 minus 126. So therefore, y is going to be equal to now 180 minus 126 is how much? It's going to be 54. If I leave my answer in this form like this, obviously in WAS they are going to mark it wrong because something is missing. What is missing there is degree. It is very important for you to indicate it there. So my y now is what? 54. Now I know my y as 54. I'm going to still apply this theorem number 1, which says that angle at the center is 2 times angle at the circumference. So in order for me to know the value of my x, so I will say my x now is going to be equal. So I know my y is going to now 2 times my y. That is angles at Angle at the center is 2 times angles at the circumference. Are you there? So I have already found the value of my y. So my x now is going to be equal to 2 times, what is your y? 54. 54 degree. Are you seeing that? So now my x, therefore, your x is going to be what? This time this is how much? It's going to be 108 degree. So this is my x. Are you seeing that? So I know my x now. I also need to find my z. Are you seeing that? So now, if you look at this z and this x, they are all at the center of the circles. Are you seeing that? So I'm going to add these two. So if I add them, all of them, their sum is going to be equal to 360 degree. So I will say my z plus x must be equal to 360 degree. Their angle at the point is added up to 360 degree. So I have already know my x. So my z is going to be equal to, what is our x? 108. So it's going to be now 108 degree is going to be equal to 360 degree. Now my z is going to be equal to 360 minus 108. So therefore your z is going to be equal to what? 52 degrees. So this is our z. Now there is another method also whereby you can use to find the z without using angle at the point. Now in order for you to know that, if you look at this angle here, it's at the circumference. So what you will do here, just take your calculator, multiply this angle by 2, you will get this angle that is at the center here. Take your calculator, multiply 126 by 2, because we said theorem number 1 says that angle at the center is 2 times angle at the circumference. So just take 126 multiplied by 2. How much are you going to get? It's going to 200. So you can say, or you can say also say that your z is going to be equal to 100. You can say 2 times 126 degree. That is, angle at the center is 2 times angles at the center. Center is 2 times angles at the circumference. Angle at the circumference. So if you multiply this one, that is going to be, therefore our z is going to be equal to what? 52 degrees. So this is our z. So someone can use this one, someone use this one, you all get the same thing. I seen that. So this is a major problems when you come in terms of WAS exam. A lot of students, they find it difficult under this area. But mastering the theorem also will help you for you to solve questions in this area. So today we are going to stop here till further notice, inshallah. The other class also, maybe we will go to theorem number 3. Then that is going to be angle on the same segments. We are going to start that one. Then from there we move to the other theorems, inshallah. So thank you so much.